Okay, guys, welcome to Chapter 10 Notes, Section 10.1, Exponential Functions. I'm sure you will be thrilled to see that there are a couple word problems to start off with here. I'm going to read this real quick to you. Could have read it yourself, obviously. Chatty Chris Kringle, wonder who that is, like spreading naughty rumors about students. Chris knows telling just one person the rumor will make it spread like wildfire. If each person that hears the rumor tells two other people, how many new people will know the rumor on the 25th round of phone calls? So real quick, play along, get a number in your head. 25 rounds of phone calls. Whoever gets a phone call calls two more people. How many people do you think are going to know this rumor when it's all said and done after 25 rounds of phone calls? Just think about that for a second. Play along. Put a number in your head. All right, now down here, the scribbled out area actually has the function or equation that we're going to come up with, but I didn't want you to see that right away. So let's just start off by making a chart. I'm going to say X represents phone calls, and then Y, which is missing, is going to represent how many people know. So 0 phone calls. Well, someone still knows the rumor. That's Chris Kringle. So in all reality, one person knows that. Best way to do a problem like this, I think, is to make a chart. So let's make this Santa here. Happy Santa. All right, he's about to, so 0 phone calls. He is about to make a phone call. So he calls someone, and this one person, one phone call, now knows. So if you think about it, there are 2 people that know the rumor now. Santa knows the rumor, and this one other person. Total 2. Round 2 of phone calls. The one person, and it says in the directions, every time a person learns about the rumor, they call 2 more people. So made a second phone call, and total them up. 1, 2, 3, 4 people know the rumor. Round 3 of phone calls. This person calls 2 people. This person calls 2 people. Total them up. 1, 2, 3, 4, 5, 6, 7, 8 people now know the rumor. 3 phone calls. 8 people. So I want to go one more for you here. 4 phone calls. 2 people. 2 people. 2 people. 2 people. 4th round of phone calls. So I'm going to bore you with that. Total it up for you, and that ends up being 16. So I would hope that you would see a pattern here, which, based on any number of phone calls, this guy is doubling each time. So if you're doubling it, that's like taking a 2, double, and using an exponent to tell you how many times you're doubling it. So that would have been the function that we're trying to come up with. So y equals 2 to the x power. So this will give you a little demonstration here of what an exponential graph looks like. Go ahead and graph that. So if I had 0, 1, that'd be right there. 1, 2, 2, 4, 3, 8, and I'm going to run out of room. But as you can see, 416 would be way, way, way up there. So the point of the graph is to show you that exponential functions climb or become large values in a hurry. So the problem itself asks for 25. So after 25 rounds of phone calls, well, the function that we came up with was this. So if I were to stick 25 in for x, that would tell me exactly how many phone calls. So I've already done it on my calculator, and I'll just write it off to the side here. So see if you came up with a staggering number. You can check it if you don't believe me. 2 to the 25th power, or how many phone calls, or how many people know the rumor would have taken place, is 33,554,432 people. So how close did you come to guessing that? So exponential functions, staggering. Imagine that was with money. Imagine how fast you could make money if you started saving. Compound interest has that effect after several years. All right, so that's one word problem done. We are supposed to name the domain and range as well, though, so let me do that. So remember, domain is just in terms of left to right, axis, horizontal axis. So domain, well, what's the furthest most left point? It starts right there at 0. and it gets bigger and bigger and bigger and progresses off to the right forever. Now, granted, it's going up mostly, but it is going off to the right as well. So how do you do that mathematically? Two ways. We could write the x's are getting bigger from 0, or interval notation would be this deal. Starts at 0, goes forever. So we have talked about both of those. That is my attempt at a parenthesis, by the way. The range. Well, range is the y values. Y-axis goes up and down. So does it go down forever? No, it bottoms out. It has a bottom. So what's that y value down there at the bottom? It's 1, but it does go up forever. So two ways of writing it. The y's start at 1 and keep getting bigger. Or same deal as the domain. They start at 1 and they go forever up. And that is all she wrote for that one. So I'm going to give you a quick synopsis of this second one, because I'm not going to have enough time to do the whole thing. But so if you read through it, it basically says something about me starting teaching in Indian Valley 26 years ago. So make a table kind of like the last one we just did. So we could say year 0, like when the first day I showed up for school. Bunch of students roaming around the building, and everybody who has me on the schedule, according to the problem, says 128 of those people have brains in their head, legit brains. Then it goes down by 7/8. So after the first year, it goes down by 1/8. When you think about it, guys, if it's going down by 1/8, that means there'd be 7/8 left. Put that on a calculator, it comes out to 112. So the second year, that original 128 went down by 7/8 the first year. Well, it's going to go down by 7/8 the second year. And now you're down to 98. Third year, had 128 to start with. First year went down 7/8. Second year went down 7/8. Third year went down 7/8. That comes out to 85, 75. So basically what we're saying, after X number of years, no matter what, we're starting off with 128. And for year 3, 3 7/8. For year 2, went down with 2 7/8. Year 1, 1 7/8. Well, we're doing exponents, exponential functions. So if you don't know what x is, well, that's how many times I would have written 7/8. So we just created a function that demonstrates what's going to happen with these students. So to find the answer, we would plug in, I'm asking after 26 years, which is currently this year, plug it in. So I got 128 times 7/8, 26 years. So 7/8, 26 times. What would have happened? Excuse me. This is supposed to be a times right here. Parenthesis. Anyhow, plug that into a calculator. It comes out to approximately 3.98. Or about 4. So what I'm saying is there's only 4 of you left that have a legit brain in your head. Just kidding, folks. It's just for fun. But if you did look at the graph, I would hope it would occur to you, so I'm going to make a real quick sketch here, that if we started off with 0, 128, that'd be way up here, and then it's just going down little by little by little. So eventually, think about it, you can't get negative brains, although sometimes I wonder about you guys. So it gets really, really close to the x-axis, and eventually we're down to almost nothing as far as brains goes. So domains, kind of like the last one, it's going from 0 forever. And the range started at 128 and went down. So you always put the bottom first. So negative infinity, well, take that back. Can't go below 0. So the range would be 0. Doesn't quite get to it. Clear up to 128 is a possibility. So really, the only thing left to ask you is, was that exponential growth or decay? Decay. And here's why. There's a fraction. If you're doing growth, guess what? There wouldn't have been a fraction. So this guy had a 2 right here. All right. See ya. Thanks for watching.